Let's talk a little bit about wind energy. Wind turbine technology generally falls into small distributed turbines to provide power directly to an owner, up to large or utility scale turbines to provide wholesale power. The small turbines, such as the one on the far right of the page, range from several watts in capacity to 10 to 50 kilowatts. Utility scale turbines range from about 600 kilowatts up to 5 megawatts, which with larger turbines even bigger than 5 megawatts, sometimes appearing offshore. The odd-shaped egg beater style windmill pictured is a Darius vertical axis wind turbine. And here's an interesting vertical axis wind turbine as well. Some of the larger turbines are pretty large. So how big would a 2 megawatt turbine span? Well, this picture compares the size of a 2 megawatt wind turbine, actually somewhat underestimating the blade diameter, but compares it to a Boeing 747 jumbo jet whose wingspan may range from 60 to 70 meters, as these 2 megawatt wind turbines may range from 70 to 80 meter in diameter. And notice the hubs sit 60 and more meters off the ground. So these wind turbines are huge, definitely huge. They sit all around the world. The pictures show a couple of installations. The bottom right picture illustrates a 5 megawatt turbine being lifted into position with 120 meter hub height, has 126 meter diameter blades. And the table lists several models in the above 2 megawatt type rating scales. As a result of increasing the capacity of these huge wind turbines, the price of wind has dropped significantly, being less than even natural gas since about 2005. And in general, renewables are starting to look pretty good economically compared to the fossil fuel and nuclear options. So notice the levelized costs comparison shows wind, onshore wind being the most cost effective. Then some of our standard, they're even competing with some of the standard generating technologies. But notice that all of the renewables are significantly lower cost than the gas peaking plants used in by many utilities. So both solar photovoltaic and solar thermal, while now competitive with the fossil fuels, those prices are continuing to drop. But we'll see that wind is still ahead, at least in 2012 dollars. The argument often comes up that these energy technologies do have some impact on jobs. So it turns out that some of the most sensible energy options, in particular the energy efficiency and solar photovoltaic, turn out to employ more people per gigawatt hour than do many of the other technologies. But solar thermal and wind tend to employ plenty of people. In terms of the job years generated per gigawatt hour, this study from UC Berkeley concludes, we find that all non-fossil fuel technologies, that's renewable energy, energy efficiency, low carbon, create more jobs per unit energy than coal and natural gas. Aggressive energy efficiency measures combined with a 30% renewable portfolio standard target in 2030 can generate over 4 million full-time equivalent job years by 2030. So renewables can have some great benefits for the economy, in spite of the arguments claiming that efforts to fight global warming are job killers. It's just plain not true. Fortunately, the economics are powerful enough to push renewables into extraordinarily high growth rates. So these show the numbers over the 2000 to 2009 years, 20 to 30, even over 30% growth rates in wind and solar and geothermal, and even in biodiesel, but growing much more rapidly than some of the other more environmentally damaging fuel sources. People complain that wind turbines have the problem of causing too many bird deaths. So let's look at the data. It turns out that bird collisions with wind turbines are a small fraction of causes of avian mortality. The number of birds impacted as a result of collisions with wind turbines will never exceed an extremely small fraction of human-related avian fatalities. Only about 2.8 birds per wind-powered megawatt are lost annually as a result of U.S. wind energy generation. That's less than 200,000 birds per year based on current installed wind capacity, according to the most recent analysis of data from 109 post-construction studies performed at 71 facilities across the U.S. These data come from the Committee on Environmental Impacts of Wind Energy Projects, a study performed by the National Research Council in 2007. In fact, less than 3 in 100,000, that's 0.003% of human-caused bird fatalities are attributed to wind energy, according to this 2007 study. Significantly greater causes of bird mortality exist. To put the wind energy impacts into perspective, consider other significantly greater causes of avian mortality, including collisions with buildings, estimated to kill 97 to almost 1 billion birds annually, collisions with high-tension lines, which kill at least 130 million birds annually, collisions with communications towers, which kill between 4 and 5 million based on conservative estimates, but could be as high as 50 million birds annually. Cars, they kill 80 million birds a year. Environmental toxins, including pesticides, kill more than 72 million birds annually, and domestic cats, which by historical estimates kill hundreds of millions of songbirds and other species annually, although a more recent study suggests higher numbers. Other energy sources pose greater risks to birds than wind. Wind power poses no population-level risk to birds, according to a 2009 comparative analysis of the impact of 6 electricity generation types on wildlife. This study comes from the New York State Energy Research and Development Authority. After considering the effects of pollution and climate change, the study concluded that non-renewable electricity generation sources such as coal and oil pose higher risk to wildlife than renewable electricity generation sources such as hydro and wind. A nice anecdote comes from the following statement that more than 3,000 wind turbines operating near the Altamont Pass in California would have to operate for more than 500 years to have responsibility for the same number of birds the Exxon Valdez oil spill killed in less than 1 week. People also have some concern about bat kills, measured bat kills from wind turbines. Questions remain there. That study concluded, we do know that many bats, like birds, die due to collisions with lighthouses, communication towers, tall buildings, power lines, and fences. But as with birds, the number of fatalities due to wind turbines is extremely low compared to collisions with other man-made structures. And we probably don't need to talk about roadkill either. Anyway, this is a concern that comes up when wind power gets considered. What is the capacity for wind power production in the United States? Well, data from the National Renewable Energy Lab, I'll give you the 2011 data, even though this is a 2010 map, that in 2011, U.S. wind power capacity installed was about 35 gigawatts. The potential for an 80-meter hub height wind turbines operating in windy areas at 30% or higher capacity factor is 10,500 gigawatts. And if you go up to 100-meter hub heights, the number increases to 12,125 gigawatts. So if you recall that to produce that the U.S. needs the world needs about 20 terawatts of carbon-free power, just North American wind can provide 10 to 12 terawatts. So that's pretty impressive. Some concern exists about the total amount of land area required to produce wind power for the U.S. So it turns out that because wind remains compatible with multiple other land uses, it doesn't require much actual land area. The total land area, if you include those multiple uses, seems a lot bigger. The map compares the amount of land required to produce 30% of the nation's electricity from either solar power, geothermal, or wind. Certainly a combination of those three can go a long way towards alleviating our electricity requirements.